Welcome back to the another tutorial of 10th class SSC Maths. Chapter 3 Polynomials. A polynomial in X is an algebraic expression containing sum of finite numbers. Okay, it should be countable numbers, which should be in the form of ax power n, where the value of a is real numbers and the value of n are whole numbers. And the value of a should not be 0. So that is what it's saying. We'll see an example how a polynomial looks like. Here 2x is a polynomial where 2 is a, x a variable, and when there is no power, the power is always 1, right? So 1 is a whole number? Yes. Is 2 a real number? Yes. So it is a polynomial. It satisfied the explanation. What about this? We have 4 as a, which should be a real number. It is. We have a variable, but we have the power 1 by 2. A 1 by 2 is not a whole number, right? We need the value of n as a whole number, whereas 1 by 2 is not a whole number, so it is not a polynomial. This is a polynomial, so as this. But what about here? Again we have minus 1, which is not a whole number. A negative value doesn't include in the whole number, so it is also not a polynomial. 1 by 3, a real number? Yes, it is in the form of p by q, right? Rational and irrational, they consist of real numbers. It is a rational one. We have x. If there is nothing, we have power 1 and a constant. It is a polynomial. Similarly, we have variable. If there is nothing, then it is 1. We have power as whole number. It is also a polynomial. Here we have constant. We don't even have the power as decimal or negative value, but it is not a polynomial. Why? Because the variable x is in the denominator. It should be in the numerator. Look, here it's in numerator, here it's in numerator, here it should never be in the denominator. So this is also not a polynomial. Degree of polynomial. So what does this say? If p of x is a polynomial in x, the highest power of x in p of x is called degree of polynomial. Suppose we have a polynomial 3x plus 5. So what's the power? Power. Degree means power. What's the power of x? If there is nothing, the power is always 1, right? The degree of polynomial is 1. Here, what's the power of x? 2. But we also have 1 here, right? But we are taking 2. Why? We should take the highest power. That is what the degree of polynomial says. The highest power is known as the degree of polynomial. Polynomial of degree is here 2. Next, linear polynomial. What does this say? A linear polynomial consists of degree of 1, such as here we have 3x plus 5. Similarly, we have 7y, 5z minus 3. These are linear polynomials. So these polynomials consist of monomial and binomial, means with a single set and a dual set with a constant. Monomial, we don't have more than 2 here. It's only 1 and 2. That is linear polynomial. Quadratic polynomial, which has power degree 2. It also consists of monomial, binomial and trinomial, which means we have 3 sets. Monomial, single, binomial, double, trinomial is 3. 8x square plus 6x and a constant plus 5. With the degree 2 is quadratic, with degree 1 is linear. And we also have cubic polynomial with the degree 3. As the name says, cube 3. It also consists of monomial, binomial, trinomial and more than 3. We can take as much as we want in this. Right? It is monomial, binomial, trinomial and it's more than 3. We have power 3, 2, 1 and a constant. We have 4 here. Now, value of polynomial. So what does this say? When we are substituting any value in place of x, then the result is known as value of polynomial. Let's read the explanation. If p of x is a polynomial in x and if k is a real number, any number that we can substitute in place of x, we are taking it as k. Then the value obtained by substituting the value of x is equals to k. Then p of x is called the value of polynomial. As we see here, we have got the polynomial p of x as x square minus 2x plus 3. For example, let's take the value of x is equals to 1. 1 square minus 2 into 1 plus 3. 1 square is 1 minus 2 into 1 is 2 plus 3. We got 3 plus 1 4 minus 2 2, right? So 2 is the value of x square minus 2x plus 3 at x is equals to 1. We need to specify what value we are taking of x. Real number can be any number, right? So we should specify while taking which value we are getting this answer. So this is known as value of polynomial. Similarly, if we take p of 0 as p of 0 instead of x, we got 3. Then 3 is the polynomial value at x is equals to 0, because when we take 0, we got the value 3. We can take any number here and find the value. Zeros of a polynomial. So what does this say? Similar to the value of the polynomial, when we substitute any value in place of x, if we get the answer as 0, then it is known as zeros of the polynomial. It is no different than the values, but as we got the answer in the above as 2 and 3, instead of those, when we are substituting any value instead of x, we need to get the answer 0. See an example here. Let's take the value 3 minus 1 and 2 instead of x. We got x square minus 2x minus 3. We got 3 square minus 2 into 3 minus 3. 9 minus 6 minus 3. Minus 6 minus 3 equals to minus 9. 9 minus 9, 0. So this is known as 0 of a polynomial. Let's take minus 1. Minus 1 square. Minus 2 into minus 1 minus 3. Minus 1 square is 1. Minus into minus plus. 2 into 1 is 2. Minus 3. We got 2 plus 1, 3. 3 minus 3, 0. We got again 0. Now let's see, we take 2. 2 square minus 2 into 2 minus 3. 4 minus 2 into 2 is 4. 4 minus 4, 0. But we still have minus 3 here. So it is not a 0 of a polynomial. As we can say, using 3 and minus 1, we got the zeros of the polynomial. But 2 is not a 0 of a polynomial because its value is minus 3 and not 0. Jump to exercise 3.1. So what's the first question here? 5x power 7 minus 6x power 5 plus 7x minus 6. We need to find what is the coefficient of x power 5. These things before before the variable, what are the numbers are known as coefficient. So we are asking the coefficient of x variable x power 5, which is minus 6. That's it. Next, we need to find the degree of the polynomial p of x. So what was the degree? Power with the highest value, right? So 7 is the highest power. So 7 is the degree of polynomial. Constant term. Constant term are known as which doesn't have any variable. This have variable x power 7. This have variable x power 5. This have variable x. But this 6 minus 6 here doesn't have any variable. So it is known as a constant term. The answer is minus 6. Second question. State which of the following statements are true and false. We got some statements. We need to answer them. The degree of polynomial root 2x square minus 3x plus 1 is root 2. Is it a degree? No. Of course, the power is a degree, not the root 2. It is a coefficient of x square. It is not a degree. So it's false. The coefficient of x square in the polynomial is 2. Where is x square? Here. So what's the coefficient? It's minus 4. Is it 2? No. False. The degree of constant term is 0. Yes. Do we have any degree here? 2 power? Is there any degree? No. So it's 0. Yes, that's true. For any constant term, degree is always 0. That is the reason we have, right? Now, 1 by x square minus 5x plus 6 is a quadratic polynomial. False, because again the variable should not be in the denominator, so it is not a polynomial itself. It cannot be quadratic or anything. Reason, it is not a polynomial at all, because the variable is in the denominator. It should be in the numerator. Fifth one, the degree of polynomial is 1 more than the number of terms in it. Well, any degree of polynomial is nothing related to the numbers. So it is false because degree is the highest power value. It has no relation with the number of terms. Degree of polynomial is not related with number of terms. That is what the reason we have. If p of t is a polynomial with t cube minus 1, find the value of p of 1, p of minus 1, p of 0, p of 2 and p of minus 2. So we need to substitute the values in place of t. 1, minus 1, 0, 2 and minus 2. Let's go with 1 first. 1 cube minus 1 equals to 1 minus 1, 0. Minus 1 cube minus 1. Minus into minus plus. Again plus into minus minus. I'll show you once. Minus 1 into minus 1 into minus 1, right? Minus 1 into minus 1 plus 1 into minus 1. Plus into minus minus 1. So that is why we got here minus 1 and this minus 1. Answer is minus 2. 0 cube 0, minus 1, we got the minus 1. 2 cube is 8. 8 minus 1, we got 7. Again, cube is 8, but 3 makes it minus again. Power 3 makes it minus again. Minus 8 minus 1, minus 9. That's it. Next question. Check whether minus 2 and 2 are zeros of the polynomial, where the polynomial is x power 4 minus 16. Let's take the polynomial and substitute first minus 2. Minus 2 means power 4. Minus 2 into minus 2 into minus 2 into minus 2 4 times. So the minus goes to plus. When it is odd power, the minus stays minus. When it is even power, the minus goes to plus. 16 minus 16, 0. Yes, it is the 0 of polynomial. Let's substitute 2. We get the same answer, 16. 2 power 4 is 16. 16 minus 16 is equals to 0. Again, these two are the zeros of the polynomial. Fifth question. Check whether 3 minus 2 are zeros of the polynomial x square minus x minus 6. So the given polynomial is x square minus x minus 6. Let's substitute 3. 3 square minus 3 minus 6. 9 minus 3 minus 6. 9 minus 9, 0. Let's take minus 2 is 4. Minus of minus turns to plus. Minus 6 as minus 6. 4 plus 2, 6. 6 minus 6 again 0. We see these two gives the value 0. So 3 and minus 2 are zeros of the polynomial. So this is the end of today's exercise. Thank you.